Okay, we want to talk about a term that's sometimes used in the description of rotational motion. It's called radius of gyration. You remember moment of inertia. Moment of inertia captures how mass is distributed in a system, right? So further out, masses count more because the radius is square. Then the masses are closer to the axis. You probably know that. I hope you know that. So if you look at moment of inertia of a particle, which is this the axis, and the particle is over here with mass m, and it's going around this axis in this circle of radius r. Then the moment inertia of this particle is just m times r squared. But this is a very special formula. If I have a disk, or you might even remember that if I have a disk like so, and here is the axis, and maybe it's really at the end, and this length is L, and the disk is rotating like that. Disk is rotating like that, and disk is mass, and this is the axis is over here. Then I of bar, let's call this axis A because this is not going to the center. This is 1 over 3, I'm sorry, 1 over 3 m L squared. When bar is at the center, this is the axis, I'm going to rotate about that. Then I of the bar to the center of mass about O is 1 over 12 m squared. When I have a disk, not sphere, disk, and I have like a computer disk, when this is a axis and I'm rotating about that, so about the center, I disk about the center. This is 1 over 2 mr squared. This is r. So they are not all similar to this, okay? We would like to write, say the center ones. We don't worry about this. This is non-center one. So we like to write all the center ones as if it looked like that. So somehow I need to take this and call it as some distance, right? So this will be distance squared. So, and here I need to kind of put them together as some kind of radius squared, and that is the radius of gyration. So if you say, don't give me this formula, you tell me you give me a different rule. You give me the same thing but different rule. Say m and rg squared. Give me this way, and this will call radius of gyration. So the radius of gyration has to be equal to 112 m squared. That means the radius of gyration of a bar, if you square it, has to be equal to 1 over 12 L squared. So this stands for it. Another way to look at it is, if I thought of this bar and I have this axis, and where would I place entire mass of the bar at what distance, so that moment inertia of this fictitious thing is same as the moment inertia of that. So I'm asking, I take the same mass as this guy, but instead of distributing over the bar, I put at one point. How far away from the axis I have to put it, so that its moment of inertia has to go to that. That's kind of abstract way, or another way, just say I'm going to just factor out m, and everything else I'm going to call a a physical quantity called radius gyration square. And so it gives nicely encapsulates the influence of the different kinds of length scales in the system. Like length here, when it's the center, you can say Rg is like 1 over square root of 12 over m. Over here, if I do the same thing, the radius gyration for this system will be m radius of gyration of this systems. I equate this is going to be half of r square, so radius gyration square has to be half of mr square, half of r square, which means radius gyration is 1 over square root 2 of the radius of the disk. So because some of the masses are closer to the center, actually masses are not, if I wanted to put all the masses at one point, the distance has to be not the entire radius, but 1 over square root 2 radius. And if the moment of inertia of this system will be the moment of inertia of this disk. That's what it's saying. So sometimes people use this radius gyration concept to kind of unify the language for different types of systems. Okay, and it's a very neat thing because rather than having a detail of it's a bar, it's a disk, it's a sphere, it's a ring, whatever, different systems, rather than that, the detail to hide the detail of the system and just focus on the concept of moment of inertia. People use this concept, and you'll see in some of the problems. Okay, so hope this helped.